Last class, we have started solving linear equation in one variable. We have seen equations with integers only. We also have solved equations with decimals. And today we're gonna see how do we solve a linear equation involving fractions as the first topic today. Let's look at this example. Let's look at this question. This is a linear equation in one variable. Question, how many terms? How many terms in it? This is all I always do. I draw a line to separate the left side of the equation and the right side of the equation. Anyone can remind me, or tell me how many terms are in this equation? 3. Thank you, Sean. Exactly. 3 terms. I want this one. 3 terms. The first term, on the left side, we have 2 terms, right? The first term is a variable term. Numerical part or coefficient and with the variable. And the second term is a constant term. On the right side, we also have a constant term, is -1 over 5. So that's the structure of this equation. Do you guys also remember what is the goal every time we solve a linear equation in one variable? The goal is always to isolate variable x on the left, sometimes on the right, but this one we are going to isolate the variable on the left. That is the goal. Very important. Whenever you do something, you have to be clear about what's your goal, what's your objective, what's your destination, right? You jump in your car, you have to have a destination in your head or on the map. I mean, a navigation. Okay, so I'm going to use 2 different methods to solve this equation. The first method, nothing special, just to treat them as 2 types of variables, the 3 terms. 1 over 10x is the term with variable. The other 2 terms are constant. So since our goal is to isolate x on the left, I'm going to apply the transposition of terms to collect like terms. Yeah, let's keep 1 over 10x on the left side. Nothing has changed to that term. 1 over 10 times x, that term stays on the left side. And then we have -1 over 5 on the right side. We are going to keep that term on the right side as well. What's going to change is this term. This constant term 5 over 2. It is on the left side, but we wanted it to on the right side. Yeah, do you remember my transposition of terms? We move it over and then we change the sign. As I emphasized before, when you change the side of the term from the left side to the right side or from right side to the left side, when you change the side of the term, you need to change its sign as well to its opposite. If it was positive, now you have to change it to negative. If it was negative, now you have to switch to positive. 5 over 2, the yellow term, was a negative, was a positive on the left side. We wanted it to on the right side. Okay, just move it over, right? It doesn't appear on the left side anymore when you move it over. Like when you move yourself from Tulsa to LA, Tulsa doesn't have you anymore. LA is gonna have you, right? So when you move the yellow term from the left to the right, on the left side, you don't have 5 over 2 anymore. You only have a 1 over 10x. On the left side, we used to have 2 terms. Now we only have 1 term left. On the right side, we used to have 1 term. Now we're going to 2 terms. We have 2 terms. The extra term we got from left side, the 5 over 2. Yeah, the sign has changed to -5 over 2. After we collect like terms, we are going to combine like terms. On the left side, we have 1 over 10 times x by itself, so there's nothing we can combine. On the right, we have Yeah, I'm going to process or simplify the right side in this box. That's how do I organize things. Let's write the right side in the box. Negative 1 over 5 minus 5 over 2. Okay? Fractions, I know. You probably hate it, especially when the calculator doesn't do wonder with the fractions. Well, we are adding, in fact, we are adding, right? Yeah, so we are adding the two negative fractions. Remember, when we add or subtract fractions, we need the two fractions have the same denominators. If they don't have yet, like these two fractions, they do not have the same denominators yet. We have to find their least common denominator. Yeah, the least common denominator, remember, is the least common multiple of the two denominators, 5 and 2. That's something we went over from the first unit, right? 5 and 2. 5 and 2. 5 is no. Oh yeah, Jamieson. Oh, Joe said you like fractions. Yeah, I like fractions too. It's actually not many things in it. If you be patient and grasp those key things like GCF, LCM, we do use GCF and LCM a lot for operating fractions. If you grasp those things, you probably would start to like fractions. Oh, you do not. Sorry, my bad. Sorry about that. Okay, so let's be patient with this question. Anyone can tell me what's the least common multiple of 5 and 2? Let me remind you, 5 is prime, 2 is prime. Yeah, so the two numbers are co-prime. Second special case, 10. Awesome, very good. Exactly, it is 10. We are going to rewrite the two fractions to their equivalent fractions with the denominator 10. What we're going to do is the first fraction, top and the bottom, we multiply 2. Second fraction, top and the bottom, multiply by 5. Right? That's how do we change or convert the two fractions to their equivalent fractions with the denominator 10. From 5 to 10, we are missing factor 2, so that's why we multiply the first fraction, top and the bottom, by 2. The second fraction, denominator was 2. From 2 to 10, we are missing factor 5, so that's the reason we multiply top and the bottom by 5. Let's see what do we have after. Keep the sign, okay? Both fractions are negative. So the first fraction becomes 2 over 10. Second fraction, 5 times 5, 25. 2 times 5, 10. Yeah, 25 over 10. Now they have the same denominators, right? Yeah, I hope you still remember my rule. When we add the two fractions together and they already have the same denominators, let me write the rule again. We use it actually a lot. Keep the bottom, solve the top, simply reduce the result. Yeah, reduce or simplify. Reduce the result. Keep the bottom, solve the top, reduce the result. Yeah, do not change the denominator to 20. Okay, no reason for doing that at all. We already have the denominator that we want. It is 10. Okay, keep the bottom 10. And you can see, I do not care about the sign when I write down my denominator. Denominator is positive 10. I just keep the denominator in the bottom, 10. Solve the top. This is how we solve the top. Solve the top, we include the sign. We're going to keep the negative with 2. Keep this negative with 25. Solve the top. This is how we solve the top. So we keep the bottom 10. Okay? Yeah, as you can see, if we remove these two tens, yeah, whatever left, we're gonna keep on the bottom, on the top. We're gonna keep on the top. We have negative 2 left, negative 25 left, and then just keep them copy them on the top. And then we see what is negative 2 minus 25. Negative 2 minus negative 5, minus 25, or negative 2 minus 25. Imagine you go to casino. Yeah, remember our casino method. That method works very well. So the first game you lost $2. Second game you lost $25. Altogether you lost $27. You lost. Yeah, you end up with losing because you lose for both. Of course, you end up with losing. Yeah, negative 27. Your profit is negative, so negative 27. Are we able to reduce the result? The result right now is a negative 27 over 10. We can write a negative sign in front. No problem with that. 27, if we use our bigger L technique, 27 is a 3, 3, 3. And the 10 is a 2, 5. You know the technique I teach in a class, the big L technique, very, very useful. It is the way we analyze whole numbers. We often have to analyze whole numbers, and that's the very useful way to analyze. Since 27 and 10 have no common prime factors, they are co-prime. Yeah, 27 and 10 are co-prime, so this fraction is already reduced. On the right side, let's put it back. We have negative 27 over 10. Negative 27 over 10. All right, last step before we reach our goal. Our goal is to isolate x on the left side, is to get rid of this 1 over 10, the coefficient. Question, what's your thought? Yeah, how do we remove the 1 over 10, get rid of the 1 over 10? How do we get rid of the 1 over 10? What's your thinking, like a thought? Let me remind you from before. Let's say we have an equation 2x equals 10. I just made it up, okay? Just made it up. If we have 2x equals 10, and we need to isolate x, what we would do is to divide each side by 2, right? Do you remember that from last Wednesday? And 2 cancel 2. We have x equals 5. That's how do we isolate variable x, by getting rid of, yeah, thank you, Ashley. However, yeah, I'm keeping doing this. Yeah, I'm using my OneNote. However, in this case, the coefficient we are trying to get rid of is a fraction, 1 over 10. Yeah, can we just divide each side by 1 over 10? Totally, yes, we can, but it's not very convenient when we're dividing by a fraction, right? So here, I needed you to write down a rule. I'm going to create another box. I'm going to write a rule in the box. The context of this rule is this question, the last step of the question. So you know we are trying to isolate the variable x. When the coefficient of x is a fraction, instead of dividing both sides by 1 over 10, a more convenient way is we multiply both sides of the equation by the reciprocal of the fraction. Here we have a concept, reciprocal. Reciprocal is very often to be mistaken or confused with opposite. Even I think the two concepts are so different. Let's say we have number 2. The opposite of 2 is -2. They have opposite sign. That's the reason we call them opposites, right? And the reciprocal of 2 is 1/2, because we can write 2 as 2/1. To find the reciprocal of a number, we simply interchange the numerator and the denominator. 2 is 2/1. We flip the top and the bottom. We get a 1/2. 1/2 is the reciprocal of 2. And what we have here is 1/10. And what's the opposite of 1/10? Of course, we don't need the opposite in this case. I'll just compare the contrast, the two concepts, and then you don't confuse one with each other, with the other. Did I say? Yeah, that's the reciprocal. Okay, so the opposite is -1/10. Okay, reciprocal is, you are right, is 10. I guess you guys are telling me the reciprocal. Very good. The reciprocal is 10. Okay, perfect. Yeah, I hope you can keep this. Is to show you the difference between opposites and the reciprocal. All right, guys, we know the reciprocal is 10 right now. As the rule says, instead of dividing, we are going to multiply. Multiply, use the multiplication property of identity. We are going to multiply each side by 10, or 10/1. 10/1 is the same as 1/10, right? Yeah. And then remember butterfly method. Butterfly method. Gone. And those two tens cancel each other. They disappear. If the two numbers are reciprocal of each other, they multiply to 1. That's how do we isolate x on the left side. On the right side, look here, look at that. It's gone as well, right? Yeah, so the two tens are going to become 1. So on the right side, we only have -27. Yeah, basically, what we have is -27/1 times 1/1, and you know, times 1 is just, nothing. 1 is the multiplicative identity. So on the right side, we have a -27. If you have time, you should plug in to double check to see if the number -27 satisfies the equation. We don't have, we are not going to do that in this question. So that's the first method, okay? First method. Second method is the method is actually my method, or the method I use, or trying to make my students try the method. Yeah, as you all know, you do not like fractions. Yeah, you do not like fractions. So why don't we get rid of fraction at the very beginning? So the second method, when we solve a linear equation in one variable involving fractions, is to get rid of fractions from the very beginning. Get rid of those denominators from the very beginning. Yeah, how many denominators do we have, and what are they? They are 10 to 5, right? We have three we have 3 denominators today for this question, 10 to 5. So we want to get rid of those fractions at the very beginning. Means we want to get rid of those denominators very beginning. Let's write them down, and then go ahead to find their least common multiple. I know we have 3 numbers now. Yeah, the first unit we only covered how do we find LCM for 2 numbers, but generalizing from 2 to 3 isn't that difficult. Least common multiple is the smallest common multiple. So the number we are going to find is a multiple of 2, multiple of 5, multiple of 10, and is the smallest. And try to remember the two special cases. Anyone can tell me what's the least common multiple of those three numbers? Which number is the smallest common multiple of all the three numbers? Awesome, exactly. Is 10, perfect. First special case, right? 2 is a factor of 10, 5 is a factor of 10. So that makes 10 the smallest common multiple. 10 is the smallest multiple of itself, and also multiple of the other two numbers. That makes 10 the smallest common multiple. All right, so once we find the least common multiple of all the denominators, we are going to multiply. This is a key step. Each term. Yeah, now you should be able to identify how many terms in the equation, and the sign. By the way, like for example, on the right side, -1/5. -1/5. The negative sign is with this term. Multiply each term in the equation by the LCM, by 10. Okay, by the LCM. In this case, is 10. This is the rule. Let's do that. Try not to do that in your head. Try to write down everything. I still have this line, separate the left side and the right side. And I'm going to write all the three terms. Too crowded. Leave some space. So this second term, and this is the first term. On the right side, we have one term. We are going to multiply all the three terms by LCM, which is 10. And I'm going to write 10 as 10/1. Here, here, and here. Yeah, let me know if you see what happened here. The blue color gives us the original equation, and the red color is a new thing. I multiply all the three terms in the equation by 10, by the LCM. Okay, by the butterfly method, cancel, cancel, right? So the first term become x. What happened to the second term when we multiply 5/2 by 10/1? You know, to make it even more organized, we're going to do this. Make another box and separate the box into three sections. We have three terms, right? The first term is 1/10x on the left side. Second term is 5/2 on the left side. Third term is -1/5 on the right side. And we are multiplying them by 10. It's multiplied by 10. It's multiplied by 10. It's multiplied by 10. You can do this. If that way is a little bit more too challenging, you can always organize the stuff in your box. And the numerator 10, cancel the denominator 10. Nothing left except x. So that term becomes x. And this term, in the second section, this diagonal, 2 and 10 have a common factor 2. So 2 is going to become a 1. Yeah, 2 is going to become a 1. 10 is going to become 5, because 10/2 is a 5, right? And we have a 25 here. Yeah. We break it down. I believe each single piece, the sound cut off. I'm going to leave and come back. Yeah, that's fine, Taylor. All other guys, can you hear me well?
I'm not having any issues.
Okay, thank you. Yeah, very good. Thank you. Let's go back. The last one, remember, keep the sign is a negative. Negative times the positive is a negative. And this diagonal butterfly, right? 5 and 10. 10/5 is 2. Yeah, the GCF is 5. 5 is going to become 1, 10 is going to become 2. So we have a negative 2. All right? Yeah, we break it down. We gotta create a new box and separate it to 3 sections. Each section we handle one term. So on the left side, we have x plus 25. On the right side, we have 92. It seems slow, but when you practice more, you can speed it up. When you understand the butterfly method better. And after that, we have no denominators. We have no fractions anymore, right? It's just a very simple linear equation in one variable. You can use the subtraction property of equality to get rid of 25 from each side, right? Yeah. Well, I'm trying to sell my transposition of terms to you, but I don't against if you want to use the addition and the subtraction property. It's totally fine. Add the same number to each side, as long as you can get it right. And this is positive 25 and negative 25 cancel each other. So on the left side, we have x only. On the right side, negative 2 and negative 25 add up to negative 27. We got exactly the same result. All right? Yeah, I recorded the class. I'm recording the class. So if you ever feel struggle solving a linear equation in one variable involving fractions, those are the 2 methods you can apply. If you really hate fractions, try the second one. You know you hate fractions, why don't we just get rid of it at the very beginning, right? 2 methods. I need a practice. Yeah, Jamie, exactly. We have to practice. So when we meet in the class, focus on understanding. Focus on understanding. And then after the class, you go to Pearson and you practice the problem there. There's bunch of problems, linear equations involving fractions. So here we have 2 rules in the 2 boxes. When the rules are important, I normally write them in color of red. So the first rule, when the coefficient of the variable is a fraction, again, the context is the last step of this question. And you want to write a rule next to the question. The last step, when we try to isolate x, when we try to get rid of the coefficient of x, and the coefficient is a fraction, instead of dividing fraction, you have to keep changing flip, you make it lost and mess up the numerator and denominator. And instead of dividing, we choose to multiply both sides of the equation by the reciprocal of the fraction. You're gonna know what is a reciprocal. You're gonna know reciprocal is different from opposite. And the second rule is to get rid of the fractions at the very beginning in a second method. Once we identify the LCM of all the denominators, we multiply every single term in the equation by the LCM. I'd like you to try the box method by the LCM. Organize your information, then you don't get lost, right? Okay, so that's one question. You want to try this on your own, practice on your own. Very similar with earlier. Very similar with the previous question. Can you let me know which method you like? Just a quick survey. The first method, we handle the question as normal. Collect like terms, combine like terms. When we have to deal with the fraction, we get it done in this box, in the blue box. Second method, we get rid of the denominator, the fraction at the very beginning. And then we leave us a very simple equation to solve. So that's number 1, that's number 2. Yeah, let's do a very quick survey. Which method you like better? If you like the first one, you type 1. If you like the second one, you type 2. I just want to know, yeah. 222, maybe on the fence. Okay, equal, yeah. So try both, okay? Try both. Very good. Practice time. You do have to use butterfly method if you apply the second method. Okay, I got my answer. Give you 2 more minutes. One more minute. If you have your answer, type the answer in the chat. Yeah, thank you, Amanda. Correct. Yeah, it's not a question mark. It's a period. It's correct. X equals 1. Let me, any other students, they have the same answer? Yeah, exactly. Perfect. Very good. Yeah, thank you, Kaylin. And Felina. Very good. So, what I used is the second method. I like this method better. As you can see, I multiply all the 3 terms by 21 over 1. And by the butterfly, 21 over 7. 21 is on the top, 7 on the bottom, right? We all know 21 divided by 7 is 3. So this thing disappear, and we're going to have 3 on the top. 3 times 5 is 15. So 15x equals, on the right side, 21 over 21 is 1. So the coefficient of x becomes 1. And here, 21 over 3 is 7. Yeah, we all know 21 is on the top, 3 on the bottom is 21 divided by 3. 21 divided by 3 is 7. So we have 7 on the top. 2 times 7 is 14, right? Use the blue. 14. Use red color to separate the left side and right side. We get rid of all the denominators. And now we have a very simple linear equation in one variable. And in this equation, we have two variable terms. We want them on the left side. So what we want is we want to, move this guy. 15x minus x, right? Yeah, move x from right to the left. We have a positive x become a negative x. Of course, you can get it done by subtracting x from each side. And we have 14 on the right. What happened is we move the x. And on the left side, 15x minus x. You have 15 apples. I take one from you. You have 14 apples left. So 14x on the left, 14 on the right. And this is very simple, right? Divide each side by 14. Cancel, cancel. We have x equals 1. Good job, everybody. So that's how do we solve a linear equation in one variable involving fractions. Yeah, we are going to do one more, just one more, okay? We are going to do this. Let's do this one. And we'll do it together. And not only this question has denominators or fractions, this equation, it also has parentheses. It might be a pain to you. If we have a parentheses in the equation, we need to apply the distributive property to get rid of the fraction, get rid of the parentheses, grouping symbol, right? Yeah, but there's something we can be flexible and make the path, make the process easier for us. Yeah, I'm not going to distribute first. What I'm going to do is I'm going to get rid of the denominator first. Okay? If we distribute, we have to do 4 times our multiplication. So I decide to get rid of the 2 denominators first. We have this 2 and this 2. If those denominators are gone, then we do not have fractions. And it's just a very simple linear equation in one variable. Remember, how do we get rid of the denominators? Write them down and then identify the least common multiple of the 2 numbers. What's the least common multiple of 2 and 4? Let me remind you, we have 2 special cases, right? 2 special cases, exactly. 4 is a multiple of 2. 2 is a factor of 4. First special case. LCM is the bigger number. I'm keeping, yeah. Let me just, how about, this is what I want. It's a 4. Now I'm going to multiply each side of the equation by 4. The tricky thing is, on the left side, we actually have 3 terms. 2 of them just in a group. On the right side, we also have 2 terms, but they are in the same group. So the tricky thing is, what part to multiply 4 by. Yeah, so this is when you need to see the structure. Yeah, since the first 2 terms, they are a group, 1 over 2, 1 minus 4. So as a group, we multiply this group by 4. Okay, we multiply this group by 1, 4, that'll be enough. And the second term, the second part on the left side, we have these 2. That's a common mistake because it's just a simple number, and people very easy for people to ignore the 2. But the 2 is a one term, is a constant term, so we do have to multiply that 2 by 4. And that part is a common mistake. People forget, oh, there's a 2 there, right? So the left side, the structure of this equation is, the left side is a group plus number 2. On the right side, we have another group. It's 3 over 4 times 2y minus 8. For this group, we multiply 4. Just multiply 1, 4, the whole group. Does that make sense, guys? Yeah, we only need to multiply those 3 parts. by 4. 2 of them are groups. You just keep them. Don't mess them up. Just don't mess them. Just keep them intact as a group. As a group, multiply by 4. And there's a little 2 here. Don't forget to multiply the 2 by 4. Yeah, okay. Okay, very good. So let's see. Butterfly. Forward 2 is 2, so we have 2 on the top. So the first group, the coefficient becomes 2. The group keep the same, okay? Keep the group y minus 4 in the parentheses. And then plus 2 times 4, 8. Bring down the equal sign. On the right side, butterfly. 4 over 4 is 1, so they cancel. And we still have a 3 here. Don't forget, we have a 3 here. And then multiply the group. In mathematics, every step, every time we process one step, there's a reason we do something for that step. If you don't have a solid like a theory or formula or reason to support that step, you don't do it. And just now what we did is the multiplication property of equality. We multiply all the 3 parts in the equation by 4. And now we have this left. No fractions, right? No fractions. We're going to distribute it now. We do have to distribute right now. To break those walls and set those terms free, and we can move them around, combine them, right? In the middle, we have the equal sign. On the left side, distribute. This is twice of the group. So the twice gonna go with each member. So twice of the group end up with twice of y and twice of -4. Twice of -4, -8, right? You know, this is how people forget it's a positive 8 because they are both 8. So be very careful. Being careful is a very useful, a very important thing in life, even in real life. We have to be always careful, right? 2 times y is 2y, 2 times -4 is -8. And then now we bring down the 8. We still have this 8. We don't make the 8 disappear only because we have -8 earlier. So now on the right side, this means the triple of the group. Now we are going to remove the parentheses. The triple is going to go with each member. Triple 2y, triple 2, we have 6. So triple 2y, we have 6y. Triple -8, we have -24, right? And let's see if we can simplify the left side a little bit. -8, +8, they add up to 0, right? Now they disappear together. And on the left side, we have 2y. In this case, the variable is y. Sometimes it's t or any other letter. On the right side, we have 6y minus 24. Continue to collect like terms. And in this case, my goal is going to be isolate the variable y on the right side. Isolate variable y on the right side. The reason is because I foresee if I move 2y over, I would have a positive coefficient for y. If I move the -24 over, I would have a positive constant term on the left. I don't want to handle negative sign. Sign error is a very, very big deal in algebra. People mess up the sign all the time. Sign error is something we need to pay attention to avoid. And the reason I choose to isolate variable on the right side this time is because I can avoid handling negative coefficients, right? Yeah. So what happened is I moved 2y from left to the right. So positive become negative. And I moved -24 from right side to the left. So negative 24 on the right become positive 24 on the left. And none of them are negative. I like that. So we have 24 on the left. On the right, we have 6y minus 2y. You have 6 bananas. I take 2 away. You have 4 left. 4y. If you think this is not comfortable, you don't like the variable on the right, at this point, when we reach this far, you can switch. Okay, switch the two sides. If you think that's not comfortable, then we switch the sides. Like the scale, you don't break the balance of the scale simply by switch the size of the scale. And then last step, simplify or isolate the y. Coefficient of y is 4, so we divide each side by 4. Cancel, cancel. We have y isolated on the left. On the right, 24 divided by 4, 6. Done. All right. If you have extra time, you can plug in 6 here. If you have time. Okay, so we are going to skip this question. You have plenty question to practice on your own later. Okay, so that's the first thing today. Second thing, some linear equation in one variable, they look special. They have a special look. Was that 6 for the answer? Yes, the 6 is the answer. Yeah, number 6 is the answer. When we solve a linear equation in one variable, we are trying to find the value that satisfies the equation. Okay. Actually, before we go to the next question, I want you to try 2 problems. Practice. Let's get rid of this one. Practice. Okay. Try those 2 questions. Solve those 2 linear equations in one variable. Pretty simple. They do not have fractions. Let me know the solution of this one and the solution of this one. You would have to distribute. Get rid of the parentheses on the right side. Number 1, 1 is a solution, but it is it has other solutions. Yeah, let's just wait a little bit. Let's see, do we have different answers? Let's see, do we have different answers? Zero? Well, I would say 0 is also a solution, but we have other solutions. Let's wait if we have different answers. 1 more minute. This one is different, right? Probably looks weird. Anybody have an answer on for the second question? Did you try the second question? So far we are still on solving linear equation in one variable. This chapter we learn solve linear equation in one variable and apply linear equation in one variable. We have to also cover solving linear inequality in one variable and apply it. Okay, guys, let's look at these two questions. They are different. You will see it feels different. This is my tradition. Draw a line to separate the left side and the right side. The left side has two terms, 2x plus 6. Right side is a group. Coefficient of the group is 2. So let's distribute and get rid of the parentheses. Twice of the group is the same with twice of the first member and twice of the second member. Twice of x plus 3, 2 times x, 2x, 2 times 3, 6. Okay. And what happened right now, guys? What happened right now? 2x plus 6 equals 2x plus 6. Well, if we collect like terms and bring this over and bring this over, we would have 2x minus 2x equals 6 minus 6, and we end up with 0 equals 0. You know what? This equation is special. This equation is an identity. If the equation is an identity, the equation has infinitely many solutions. All the real numbers are solutions. Why? Because look at this step. I'm going to highlight the step in yellow. Look at this step. 2x plus 6 equals 2x plus 6. The left side exactly equal to the right side. That means no matter what x equal to, x could be 1, and the left side equals the right side. X could be 0. When x equals 0, the left side still equals the right side, but not just 1 and 0. Any other numbers, if you let x be a million, the left side still equals the right side, because the left side and the right side are exactly the same. 2x plus 6 on the left, 2x plus 6 on the right. So no matter what x equal to, the left side always equal to the right side. So all the real numbers, any real numbers, would satisfy this equation. This equation is an identity. If the equation is an identity, the equation has infinitely many solutions. Identities have infinitely many solutions. All the real numbers are the solutions of the identity. Let me know, please let me know, am I clear about this question? It turns out it has infinitely many solutions. Yeah. Okay, now let's do the second one. My tradition, draw a line, separate the left side and right side. Left side we have 2x minus 6. Oh, I'm supposed to use blue color. See the Jill, what is x equals 12? Could you explain what is x equals 12? For the second question? Actually, let's see what we have, okay? Yeah. So we have 2x minus 6 on the left side. On the right side, let's distribute. Twice of x, 2x. Twice of 3, positive 6. And then we are going to collect like terms. I'm going to move this 2x over. I have 2x minus 2x. And then I'm going to move this negative 6 over. And I have 6 minus 6. You see what happened? Plus 6, my bad. Plus 6. Yeah, let me color, okay? Let me color them. So what happened is this yellow term is moved from right to the left. So positive 2x becomes negative 2x. And this negative 6 is moved to the right. Negative 6 becomes positive 6. And we have equal sign in the middle. On the left side, what is 2x minus 2x? Okay, don't worry, I know it's a 0. It is a 0, okay? It is a 0. You have 2 apples, I take them all. You have none, you have nothing. And on the right side, we do have 12. However, the solution is not 12. This is a contradiction. It is totally normal because this is our first time to see this type of equation is different, right? All the problem we have practiced so far before these 2 questions, they all have a solution. They all have one solution. And suddenly, we are looking at the 2 different, 2 special type of equations. And this one's identity has infinitely many solutions. And this is a contradiction. Why is a contradiction? Because this is an equation. The left side of the equation is 0. The right side of the equation is 12. The equation tells us 0 equals 12. How is that possible? So that is a contradiction, right? Yeah, contradiction has no solution. So the answer is no solution. Yeah, 0 equals 12, and that is a contradiction. Yeah, Amanda, 0 equals 0, that's the first question. And Joe, 0 equals 12, that's the second question. Oh, okay. Yeah, I almost forgot to change the sign. Yeah, plus 6. Change the sign is very important. Once you get used to it, it's very useful technique. Let me summarize. We are learning at this point. We are learning solving what? Linear equations in one variable. And you know what? We have 3 types. We have 3 types of linear equations in one variable. The first type is called conditional. Conditional. Second type is called identity. Identity. The third type is called contradiction. Just now we had 2 types covered, right? The first one is identity. Second one is contradiction. Identities have no solution. Sorry, my bad. Take it back. Identity has infinitely many solutions. Infinitely many. Okay, let me repeat more times. Infinitely many solutions. Identities have infinitely many solutions. All the real numbers are solutions. Contradictions have no solution, okay? No solution. Technically, contradiction has a finite number of solutions, but in our case, it only has one solution. Okay? Yeah. Again, linear equations in one variable has 3 different types: identity, contradiction, and conditional. The questions we have been practicing before those 2 questions, they are conditional. Yeah, let's see. This equation is conditional because it has one solution, a unique solution, right? Yeah, it's called conditional. Why is it called conditional? It's because this equation is true. Yeah, this scale is balanced only under the condition that the variable assume the value -27. So that's the reason we call this type of equation conditional. This equation only is correct, only is true under the condition that x equals -27. It has one solution, is a conditional. And this is also a conditional, same equation, sorry. This is also a conditional. Yeah, solution is 1. Why is conditional? Because This equation is only true under the condition x is 1. When x assumes other values, if x equals -1 or 2 or 0, and that equation is a false statement. So that's the reason the equation is called a conditional. And this equation is also a conditional. The variable y equals 6, because this equation is only true when under the condition that y equals 6. When y assume other values, like any other real numbers, the equation will be false, will be not correct, will not be correct. Yeah. So this is a conditional. But this is an identity, right? Yeah. You look at the yellow part. The yellow part here. The yellow part here. No matter what x equal to, the left side always equal. So all the real numbers satisfy the equation is an identity. And then number 2, this equation is a contradiction, because no matter what x equal to, the equation will never be true. It is always false. No matter what value we let x be equal to, the left side never equal to the right side. So that is a contradiction. That is a contradiction. Contradiction has no solution. All right, yeah. At this point, we're pretty thorough about solving linear equation. So would we put a no solution for the answer? Yes, we should put a no solution for the answer. 0 equals 12 is the last step showing us the equation is a contradiction. Yeah, 0 equals 12 is a contradiction, is a false statement itself. It is equivalent to the original given equation. Let me know, am I clear? So far, we have learned how do we solve equations, all the 3 types. And how do we solve equations with integers only, and with decimals, with fractions? Okay, awesome. And one more thing, okay? One more thing before we start a new topic. Some equation looks different. They have special looks. They have special looks. They have this structure. And they are called a proportion. You might remember that from proportion. Yeah, so many different things. Yeah. Proportion. It's just another type of a kind of special looks equation. What is a proportion? It's a butterfly shape. In the middle, we have the equal sign, right? In the middle, we have the equation has this structure. In the middle, we have the equal sign. And on the left, we have one fraction with numerator and denominator. On the right, we also have one fraction. Technically, this is not a fraction, but let's pretend it's a fraction. Technically, it's a rational expression. It's the generalization of fraction. But let's pretend, because it just only have one bar, right? So it looks like a butterfly. This is the wing, this is another wing, this is another wing, this is another wing. So it looks like a butterfly. If the equation has that kind of structure, we call the equation a proportion. Okay, a proportion has a unique, a special way to solve it. It's called a cross multiply. Cross multiply. I believe you heard about it, and it's so different from multiply cross. It's different from multiply cross. What is multiply cross? Multiply cross is when we multiply two fractions. We multiply cross, multiply the two numerators, multiply the two denominators, right? That is a multiply cross. It has nothing to do with cross multiply. Cross multiply is the technique to solve a linear equation in one variable if the equation is a proportion. It has that butterfly structure. Yeah, how do we do that? We look at the two diagonal, okay? We look at the two diagonal. What we need to do is We take one diagonal. Let's say we do the blue one. On that diagonal, we have two terms. Upper left x, bottom right 2. We're going to multiply them together. 2 times x times 2, we write it as 2 times x. We have the coefficient in front of the variable. And the pink diagonal, we also have two things, right? Yeah, on the top right, we have x minus 3. Bottom left, we have 3. So we're going to multiply them together. That is called a cross multiply. Cross multiply. And then we simplify. Left side 2x, right side distribute. Triple of the group is equivalent to triple of the first member, triple of the second member, right? And again, this time I'm going to move them to the right. Move the 2x to the right. And this 99 to the left. Don't forget, please don't forget, change the sign. Yeah, practice. What happened is I move the 2x over, so positive 2x become negative 2x. And I move the 99 over, 99 become positive 9. To do this, I do this to avoid handle negative sign. And now I have 3x minus 2x, I have x. Yeah, when you practice this method a lot, like transposition of terms a lot, some of you might be able to do that quickly in your head, I believe. Think about, just visualize it. Move the 2x over. You have 3x minus 2x is 1x. And then you move the 99 over. You have positive 9. So x equals 9. Yeah, so this transposition of terms could eventually make your solution solving the equation very quickly. What if I went the other way? Yeah, good question. Yes, and ended up with negatives. Let's try that. The other way. So let's 2x equals 3x minus 9. Let's keep 2x on the left and move this 3x over. Do we change the sign? Please don't forget to change the sign. 3x on the right is going to be 3x, negative 3x on the left, negative 3x on the left. And then we have 99 on the right side. Yeah. Advantage of this method process is you don't have to move two terms. You only need to move one term. However, on the left side right now, you have 2x minus 3x. You win 2x, and the second game you lost 3, so you lose 1x. And on the right side, you have negative 9. And what's the coefficient of x? Your coefficient of x here is negative 1. So we would have to divide each side by negative 1 to isolate the x. Cancel, cancel. We have x equals negative 9 divided by negative 1. We have a positive 9. Yeah, you would have the same answer. Try play with it. It's a very convenient method, transposition of terms. I believe if you had an Indian teacher, math teacher from school before, your Indian teacher teach the same method, and Chinese teacher me teach the same method. Yeah, American way don't have, American textbook that doesn't have that method for some reason. Okay, got it. Because I would have to eliminate the negative sign. Yes, you would have to eliminate the negative sign. Good question, Jill. All right, so that's about solving equations, okay? Solving equations. And now what I want to do is I want to jump into solving inequalities. for those questions, we're gonna leave them next time. So now I want to change the order of the sections. Our homework is by chapter anyway. Now I'm gonna jump into solving linear inequality in one variable. Linear inequality. Because when we still have something fresh, number 1, number 2, copy those two first. Okay, so now after we finish solving linear equation in one variable. Now, next thing we're going to do in this chapter is we are going to solve linear inequalities. It is plural. In one variable. Yeah, I put the two things together, align them like that. I want to show you the relationship between the two things. Yeah, name-wise, the two things only has one word different. Okay? Yeah, this is equation. This is inequality. All other words the same. Linear, one variable, right? Linear, one variable. The only words that is different is this is equation, this is inequality. And what is inequality? Inequality, so equation has equal sign. What's the difference? Equation has equal sign, so that makes it the equation. And inequality has inequality symbols. And what are inequality symbols? We have the following inequality symbols. We have this. We have this. We have this. And we have this. Okay, technically this is also an inequality symbol, but we don't solve inequality like that. We don't really solve an inequality like that. So linear inequality in one variable is something with one of those, one or two, yeah, one of those notation, a symbol, inequality symbol in it. And let me explain. And this is, the first one is greater than. Greater than or bigger than, same thing, right? Means the same. And this with the bar under means greater than or equal to. Greater than or equal to. We also can translate that as at least or no less than. No less than. Is the no less than. Yeah. Let's just do 3 of them. So yeah, I'm trying to write maybe a colon here. We have at least 3 different ways to translate this notation. And let me make a table or box them. Yeah, this is the second notation. The first one is the bigger than word, greater than. Yeah, for the second one, let's say in order to get a C from this class, your grade has to be at least, your score has to be at least 70%, right? So that means bigger than or equal to 70%, or no less than 70%. That means the same thing. Greater than or equal to 70%, at least 70%, no less than 70%. That means the same thing. means either you get exactly 70% or more than that, 71, 72, or 70.5. Yeah. So that is that notation mean. Inequality symbol. Inequality symbol. And the third one is less than. Means strictly less than, okay? Strictly less than. Because there's no bar under. And the last one with bar under, that is less than or equal to, smaller than or equal to, or less than or equal to. We can also translate that notation as at the most, or say that no more than, no more than. We use that symbol when we do budgets. Let's say this month, your wife tell you, this month we cannot spend more than, for grocery, this month for grocery we cannot spend more than $800. So it means $800 is your budget, right? You don't spend expense on the grocery, whatever. Yeah, no more than $800. Or this month's grocery we have to spend less than or equal to $800. Or this month we can spend at the most $800 on grocery, right? No more than $800. They all mean the same thing. They all mean the same thing. Means this month you either spend exactly $800 on grocery, or you spend less than $800 on the grocery. So for those notation, they have different translations. All right. So if we have something with one of those symbols in it, then that is an inequality. We are going to learn how to solve a linear inequality in one variable this chapter. And what's the relationship or connection between linear equation in one variable and linear inequality in one variable? As you can see, if you change this to equation, you have a linear equation in one variable. So all other characteristics is the same. It is linear means if you see variable x appears, the exponent on the shoulder of the variable is 1. You don't see square, you don't see cube, you don't see 1/2, you don't see x to the power -1. If the variable appears, the exponent on the shoulder of a variable must be 1. That makes it linear. One variable means you don't see you do not see the second variable. You only have one variable. Very, very simple. Okay? Yeah, since the two things are the name-wise so close, in fact, solving process also very similar. So let me write down this rule. This is to I'm going to type them. Yeah, I'm going to color them in red, so please take notes. The only difference between solving a linear, I'm going to make it bigger later. The only difference between solving a linear equation in one variable and solving a linear inequality in one variable is, the following is important. When we multiply or divide each side of the inequality by the same negative number, when we multiply or divide each side of the inequality by the same negative number, we must switch the inequality symbol. Okay, or flip. Okay, let me make it bigger. Bold it, color it. It means it's important. Okay, make it bigger. The only difference and let me know let me know after you copy it. Too big. 6 to 30. 6. The only difference between solving a linear equation in one variable and solving a linear inequality in one variable is, so earlier this chapter so far, we have only been doing solving linear equation. So the next thing we're going to do is to solve linear inequality. And what's the difference between the two things? There's only one difference. What's the one difference? When we multiply or divide each side of the inequality by the same negative number, we must switch the inequality symbol. So the key word here, multiply, divide, keyword here, and the same negative number. Okay, yeah, let me know when you finish the copy of the rule. It's very important. That means everything else is the same, right? What does that mean? Transposition of terms. The technique is still transposition of terms. This technique still applies when we solve linear inequality in one variable, right? We use that technique to collect the like terms. And yeah, everything else is the same. The only difference is when we multiply or divide each side of the inequality by the same negative number, we must switch the inequality symbol of the inequality. Okay, I think the best way to memorize it is we actually use it when we see the case and we need to apply this rule. Let's see this one. This one we do not need it, but let's see this one. This one doesn't need it either. Let me find one that we need it. Try this one. Get rid of this. Let's see. Yeah, this one needed. Okay, I know this one looks a little bit complicated compared with the other two, but I think we can do it. Okay, everything else is the same. My tradition is the same. I put a imaginary line here. Separate the left side and right side. And also, I would write my goal here. Remember the goal when we solve a linear equation in one variable? Same here. The goal is when we solve a linear inequality in one variable is also isolate the variable on the left side. Sometimes maybe on the right. Just for convenience, I'll write on the left side. And you know we are flexible on that word. Sometimes it's better isolate the verb on the right side. And that is the same with solving an equation, right? Okay. So if this was an equation, what should we do? We should simplify the left side and the right side first. Let's do that in the two boxes, okay? I'm going to simplify the left side here. I'm going to simplify the right side here. Let me copy the left side, the entire left side. 11 plus 5 times parentheses 2 minus x. And we bring down 11 and we apply the distributive property to remove the parentheses. 5 times the group. When we remove the grouping symbol, we have 5 times the first member. 5 times 2, 10. 5 times negative x, negative 5x. What is 11 plus 10? 21 minus 5x. So after we simplify the left side, apply the distributive property, remove the parentheses, combine like terms, we have 21 minus 5x. So far, on the line we bring down, doesn't change it, okay? We don't change it. We bring down the inequality symbol. On the left side, we have 21 minus 5x. Okay? 21 minus 5x, bigger than or equal to. Bigger than or equal to. On the right side, let's simplify the right side. On the right side, the entire right side is negative 2 times the parentheses x plus 3. It's going to be negative for each member because the coefficient is negative. Negative 2 times x, negative 2x. Negative 2 times 3, negative 6. So that's the simplified form of the right-hand side. Put it back, negative 2x minus 6. So far, we have not used anything new, right? Okay. Same with the next step. We are not going to use anything new. Keep this inequality symbol in the middle. I'm going to collect like terms. I'm going to move this term over and move this term over. I'm going to keep negative 5x on the left side. Yeah, since I'm going to move the yellow going to change the sign. And negative 6 stay here. And 21 change the sign, move the side. This is pink, pink. This is yellow, yellow. This is the transposition of terms. This is what happened after we collect like terms by using transposition of terms. Again, negative 5x doesn't change. Keep on the left. Negative 5x, still negative 5x. Negative 6, that term doesn't change. Yeah, you do have to note, identify 4 terms in the inequality. 4 of them. We have 4 of them. And the negative 6 doesn't change on the right, so it keep the negative 6 on the right. What has changed is this yellow term, negative 2x. We moved over, so negative become positive. Also have changed is this pink term, constant term, 21. It was a positive, now it is a negative on the right. We have the like terms collected. So far we have not using anything that we have not learned yet, right? We all have learned those things already. Left side, combine like terms. Negative 5x plus 2x. You lost the 5 chips the first game, and you gain 2 chips the second game, but you still end up with losing. But you lose less. You lose 3. So the left side is a negative 3x. Left side is negative 3x. Right side, negative 21 minus 6. The first game, you lost $21. Second game, you lost $6. So together, you lost $27. Negative 27. Okay, so now we're going to consider isolate the x on the left side. What's the coefficient of x? Coefficient of x is negative 3. Exactly. Negative 3. Yeah. So if we had negative 3, has to be negative, guys. Has to be negative. Cannot be positive. Sean, got a negative 3. Has to be negative. So the coefficient negative 3. If this was an equation, of course we're gonna divide each side by negative 3, right? Same here. However, we have a rule here. Did you write it down earlier? The rule says when we multiply or divide each side of the inequality by the same negative number, we have to switch the inequality symbol. Okay, what does that exactly mean? It means we want to divide to isolate x on the left side. We want to divide each side of the inequality by -3, right? -3 is the coefficient, not +3. But since we divide each side by -3, we must switch the inequality symbol. That's the only difference, only thing you need to pay attention. The only difference between the two solving processes. You have to switch the inequality symbol in the middle. I'll explain why in a moment, okay? So when we apply the rule, we know when do we apply the rule? When we multiply or divide both sides of the inequality by the same negative number. Like just now, we need to switch or flip the inequality symbol. And we cancel -3, we have x isolated on the left side. This time x is less than or equal to, on the right side, -27 divided by -3, +9. So the solutions are, let me write it down, okay? The solutions of this inequality are all the real numbers that are no more than 9. So the solutions of this inequality is not unique, it's not just one number. It has many, infinitely many solutions. All the real numbers that are less than or equal to 9, they are all solutions of this inequality. 9, yes, but 8.99999, you know, a little bit less than 9 is also a solution. Yeah, any real numbers less than or equal to 9 are solutions. What if I went the other way because I wanted to end up with the positive? Good question. Good question. Let's do that. The other way, let's start from here. So we have 21 minus 5x bigger than or equal to -2x minus 6. That's a very good idea, because if you can foresee the other way can get rid of negative sign, then why not, right? Yeah. Then this time we are going to keep the inequality symbol here, okay? We have no reason to do any change to that at this point. So we keep -2x here, and then we move -5x over, we have +5x. We keep 21 on the left side, move -6 over, +6, right? Do you guys see that? I can also color them. Color them is very strong pink. Too much. Yeah. So this is very strong pink. From -6 on the right, change to +6 on the left. And this green, -5x become +5 on the right. And then keep the inequality symbol, okay? Again, there's no reason to switch it or make any change to it. Left side right now, 21 plus 6, 27. Right side right now, -2x plus 5x. That's the same with 5x minus 2x, so 3x. Okay? And then you divide each side by 3. You don't have to do nothing because divided by 3 is a positive, right? So cancel, cancel. You have x on the right and you have 9 on the left. But you want to still write the answer as x less than or equal to 9. We know alligator, right? Alligator, you know, this is teeth. Yeah. So the inequality symbol, imagine the inequality symbol like an alligator mouth. And the alligator always very greedy. This is a very greedy alligator. Since it's greedy, it's always chasing the bigger quantity. Okay, so as you can see from here, let me color it as yellow. I say here means this yellow part. As you can see from the yellow part, compare 9 and x, left side and right side. 9 is bigger, right? Because the alligator mouth is chasing 9. So 9 is bigger, means x is smaller. So when you write x to the left on the left side, the alligator mouth has to turn around. The alligator has to turn around, also still chasing 9. Do you see what happened? It's like if you have 1 minus 2, if you have 1 is less than 2, is a true statement. You can also write that as 2 is bigger than 1. They are the same thing, but looks different. Did I address your question? That's how I went. Yeah, okay. Yeah, that way you have a positive 3 as the coefficient. I agree. But sometimes we do have to handle, you do encounter cases in which you need to multiply or divide both sides of the inequality by the same negative number. So that's the time you need to switch the inequality symbol. Okay, yeah, like what we did right here. Switch the inequality symbol. Let me explain now. Why do we need to switch the inequality symbol? Let's start from 1 is less than 2. And let's apply the multiplication property of inequality. Yeah, we are allowed to multiply the same number to the inequality, but we need to be very careful with the symbol in the middle. So what if we multiply each side by -5? Okay, multiply by -5 times -5. The left side times -5, we have -5, right? 1 times -5 is -5. On the right side, 2 times -5, we have -10. Compare -5 and -10, which one is bigger? Please don't tell me -10 is bigger, okay? -5 and -10, which number is bigger? Yeah, 95 and 10, which number is bigger? 95, exactly. So you can see those as dollars, right? I like to use the casino method. Do you like to lose $5 or you want to lose $10? Of course, if you can lose $5, you don't want to lose $10. So 95 is bigger than 10. Do you see that? When you multiply the same negative number, when you multiply both sides of the inequality by the same negative number, you have, interesting. So you have to switch the direction of the inequality symbol. That's why. Okay, because for two negative numbers, the one with a smaller absolute value is bigger. This is the real number line. 0 is in the middle. To the right of 0, we have all the positive real numbers. And those numbers, when you look at it from left to the right, their absolute value is increasing. Okay, this is left, this is right. But look at those numbers to the left of the 0. They are negative numbers. And if you look at from the left to the right, those numbers, their absolute value is decreasing. 96, 95, 94, 93, 92, 94. The absolute value is decreasing, right? So when you have both numbers are negative, the one with the smaller absolute value actually is bigger because it's closer to the 0. Yeah, I hope this address the why behind the rule. Let me repeat the rule again. When we multiply or divide both sides of an inequality by the same negative number, it has to be negative, by the way, we have to switch the direction of the inequality symbol. If we multiply or divide by positive, do we need to switch? If we multiply or divide by positive, do we need to switch the direction? Let me repeat my question. When we solve an inequality, we need to multiply or divide the same positive number. Do we need to switch the direction of the inequality? Okay, thank you, Sean. Another question. When we solve inequality, we need to add or subtract the same number. Doesn't matter, positive or negative. Do we need to switch the direction of the inequality? When we plus or minus? Thank you, Desiree. Exactly. The only time we need to switch the direction is when we multiply or divide by the same negative number. Any other times, don't bother, don't mess the inequality symbol. All right. So you know what? We are not really completely done with this question yet. Oh, no problem, Jill. So it's clear, right? So we are not completely done with this question yet. So earlier, we already we find the solutions. We find the solutions for all the, we find the solutions of the inequality. The solutions are all the real numbers no more than 8, no more than 9. The question you will see in Pearson, they will make you to graph the solution set. Yeah, to graph the solution set. Or the solutions of the inequality. Yeah, let me show you how do we do that. Yeah, often the question would ask you to do that. So they will give you a real number line. Okay, this is 1, 2, 3, 1, 2, 3, 1, 2, 3. This is 9, and this is 10, this is 11, and so on. 91, 92, 93, and so on. So we are going to graph the solutions on the real number line. Firstly, you're gonna mark you're gonna mark number 9 because that's the upper bound of the solution set, right? All the real numbers no more than 9. So 9 is the upper bound of all the solutions. So 9 is right here. What happened? Yeah, 9 is right here. Mark it. But I'm going to mark 9 as a solid dot. The reason is because the solutions are x less than or equal to 9. So that means 9 itself is a solution. That's the reason I mark 9 as a solid dot, here, okay? As a solid dot. And then I want to indicate all the real numbers less than 9 also as solutions. And they are the numbers or the points to the left of 9. And continue all the way to net infinity. So that's the reason I have a arrowhead here. So I graph That's the graph of the solutions of the inequality. All the real numbers less than or equal to 9. Those numbers on the real number line are to the left of the number 9. Since in this case 9 itself is also a solution, we make a solid dot at 9 to indicate 9 is also satisfied the solution. And in this case, I think you have to learn interval. Anybody know interval notation? Sometimes they need to make you to write a solution set as in the interval notation. Interval notation. What is an interval? My definition for interval is one single piece on the real number line. One piece. Look at the red part. Do you agree that is one single piece? There's no disconnection or anything or breaks in the middle, right? So that's a one single piece. And anybody tell me what does the one piece, the red piece, start from the left? That is called the left endpoint. And what's the piece stop on the right? That is called the right endpoint. Okay, the left endpoint is net infinity because the piece start from net infinity all the way to 9, right? So net infinity and 9 is the right endpoint. We have a comma separate. And we always use parentheses to frame infinity. And in this case, we use a bracket to frame 9 because 9 itself is a solution. And since we run out of time, we are going to talk about the interval notation in more detail on Wednesday. We're going to have to stop here today and continue solving linear inequality in one variable next time when we meet. All right, guys? Right, 751, yeah. Okay.
Thank you.
Thank you. Thank you guys for coming. Email me if you have any questions, all right? Just a gentle reminder, if you have not started your homework yet, that's not a very good sign because we are going to have the first exam very soon, right? Okay. I will email you about that. Have a good night, everybody. Bye-bye.